Density is the amount of stuff in a substance. In physics terms, what this means is, in terms of a formula, density is equal to the mass of the substance or object divided by the volume of the substance or object. Mass is usually measured in kilograms. Volume is usually measured in meters cubed or cubic meters. So this means that the density is measured in kilograms per meter cubed. Now you might see this differently in chemistry. You might see grams per centimeter cubed. The units that you use are usually appropriate to the substance you're talking about. So let's look at this and how we might express this in other ways. Okay, so density is mass divided by volume. We tend to refer to density in the Greek letter rho m over v. This can rearrange in a simple way. Mass, well, is equal to, right, so if we take the mass, okay, make it the subject of the equation, what we must do is the mass has to be on one side, so you can see that volume goes with there and mass will be on its own. So that will become density times volume. That's straightforward. What about if we want to do volume as a subject to the equation? Well, volume is on the bottom, so we need to bring it up to the top just as before, and so mass divided by density. Okay, let's look at a couple of problems. This first one, calculate, okay, there's the key word, the density of an osmium nugget, volume 3.2 centimeters per cubed, and mass equal to 72.4 grams. Osmium is one of the densest elements there are on Earth. Okay, it's very rare. But so let's make density, we start off with the formula. Density, that's a symbol for density, writing in words is okay, is equal to mass divided by the volume. This is the equation. Underneath it, we now show our working. So we have 72.4 divided by 3.2. We then write the answer, 22.625, but this isn't appropriate to write this many figures, particularly when we notice that the 3.2 is only two figures as well. So it means that of the three figures there, the two figures there, we should really only write our answer to two figures. So we'll write 23, now we must add the units, okay, grams per centimeter cubed, not kilograms per meter cubed because of the question units. If we notice, what we've done is we've used an equation, shown our working, put our answer, and then the unit. EWOW, equation, working, answer, unit. It's important in physics that we do that every single time. Okay, let's have a look at another problem. In this problem, we're to find the mass of the gold ring, okay, from the volume and the density we have from there. So we need to have mass the subject of the equation. Well, mass is density times volume. So put in the working, so 19.3 times 1.6, clearly that's equal to 30.6 0.88, but again the 1.6 shows us that there's 2 sig figs, 19.3 is 3 sig figs. Our answer should also be in 2 significant figures, so that's 3, 1, and the unit grams. Okay, again what we have shown is the equation first, the working next, the answer, then the unit. Okay, let's do one more. In this question, you're asked to calculate the volume. The volume is going to be the mass divided by the density. Okay, that's our equation. And that is equal to the mass of 0.343, the density 8960. Put our answer in. 0.1234 noughts, 382.815, sorry. But you can see on this one we have 3 significant figures for the 343, 3 significant figures for the 896. So I only need 3 significant figures for the volume. So I need to put 0.00038, rounding up the 8 there, into 3, and the volume is meters cubed. That is a small volume, but this is in meters cubed this time. Okay, so hopefully you can try some of the problems like that yourselves.